Now our first construct for generating concurrency is this AND split. The AND split, as you can see here on the upper right corner, contains a logical AND. These are the two lines open on the bottom. And this logical AND is surrounded by a circle. A circle such that we, in our EPC method, have this special construct here available for the AND split. For the AND split, it is possible to perform the split in two different ways. The first way is that you, at some time in your business process, arrive at an event. For example, here the confirmation is sent. So you send out some document. And after this event, you might decide to do something in parallel. Like here we have two different functions we do in parallel. The first one is recording data, and the other one is calculating cost. So you would do these two functions in parallel. And you have to pay attention again to the rules for the event-driven process chains. One important rule was to let functions only follow to events. So the same here, even if you have such an AND split in your process chain, you have an event, then you have the AND split, and after that you are allowed only to have a function. You could have other splits maybe if you construct it in a special way, but the main construct which follows then should be a function. So here confirmation is sent is followed by record data and also calculate cost. So you do both functions in parallel. Another possibility would be the second one, that you perform some function, and after you perform the function, you don't immediately come to an event. Maybe you have an AND split and you come to two different events. Two different events, which then might be followed by functions also. And these two events are here. The data are available. After the data were recorded, the data are available. And the fee finally then is calculated also. So two different events which are followed by, which follow on the function record data. And you might model it like that because it might be important for you that you have this event data available, because this then triggers the next function, and it describes that a certain sequence then is performed after the recording of the data. And the same with the fee calculated, you do it in parallel to the data available, and you might need it because you describe a certain sequence which is then done in parallel to data available. Again, here a function is followed by an event. So you strictly have to follow the rule: function follows an event and event follows a function, even if you have this AND split here in between. In a similar way, you have the AND split. You would maybe like to join two different concurrent sequences. So therefore, you have the AND join. Again, the AND join is described by the same sign, like you can see here in the upper right corner. This logical AND, two lines open on the bottom, surrounded by the circle. The circle for importing this AND join here into the event-driven process chain. And you might use this AND join to maybe join again two different concurrent sequences to one sequence, like shown here in the examples. And again, Similar to the split, you can have functions or events before your end join. So here in the first example, you assign a member ID and maybe at the same time you calculate a fee. And at some point in time, you are finished with these functions. Maybe the first function, assign member ID, is done earlier than the calculation of the fee. But essentially, you at some time finish both functions. You are finished with both functions at a certain point in time, and then, if you are finished, the end join is activated. You finished both sequences. The end join aggregates these two sequences, and one common event comes out from these two sequences. The one common event, contract data known. So you aggregate these two sequences, which somehow contain the assigned member ID and the calculation of the fee, which were done in parallel. You join them together so that you only continue with one sequence of events and functions. So that's the first possibility, actually, to perform such an end join. The second possibility would be that you arrive with events at such an end join. Here in the lower example, the member ID is known, that's an event, and the fee is calculated. You finish the calculation of the fee. Maybe just a different method to describe the same what is described in the first example. But anyway, it's an event here which is reached before your end join, and then your end join aggregates these two sequences to one sequence together. So you perform the function fill out member form after you reached these two events. The end join also dictates in both cases that you have to join when you come from both sequences together. So it's not allowed to arrive only with one sequence. For example, in the lower example, that you say you know the member ID, but the fee is not calculated. But anyway, you perform the end join and you fill out the member form. That's not possible. That's not allowed. You only can fill out the member form if you arrive with both events. If you arrive with member ID known and fee calculated. That's actually the main character of the end join. You have to have both sequences finished with these events. And then you're allowed to perform the end join and to continue with fill out member form. The same with the first sequence, with the first end join. You have to finish both functions, and if you are finished with only one function, you're not allowed to go to contract data known. You have to finish assign member ID and calculate fee. And maybe one function is finished later, then you have to wait at this end join. Again, as you can see here, you have both possibilities. You can start with functions, then do the end join, or you can start with members, with events, and then after the event you do the end join.